So under our topic that we were doing last, that was correlation and regression analysis. We started with the correlation analysis, whereby we say this one is used to determine the strength and direction of independent and dependent variables. And then under that one, we saw there are two types of coefficients we are supposed to determine. That was the Pearson correlation coefficient, or sometimes called the product moment coefficient of correlation, that is small r. We saw its formula, that was r equals to n summation of xy minus summation of x summation of y over n summation of the square of x minus summation of x into bracket squared. I think you can be having a conceptual on how that one is written, into brackets times n the square of y minus the summation of y squared. All of that should be the square root. That was in the determination of the Pearson's correlation coefficient, or the product moment coefficient of correlation. And then below that, we determined the coefficient of determination, where we were supposed to square that small r to determine the coefficient of determination. And we agreed that a negative shows the negative correlation, and a positive shows the positive correlation. And then now the strength lies in how the number is from 0 to 1. We next did the Spearman's rank correlation, or the rank correlation coefficient, that is capital R here, which is here. That was the part B. That was calculating the correlation or the relationship between the ranks, where we use this formula r equals to 1 minus 6 summation d squared over n cubed minus n. This one was done. Now there is this part where if the ranks are repeated, as you can see down here, for example, we have the scores of students, the 1 to 9 students, that is n is 9. Then there is this marks for quantitative methods, cost accounting. We have 35, 55, 45, 50, 25, 45, 29, 52, 45. Watching keenly, you can see that there are some ranks which are to be repeated here. Like for example, 45, 45, 45 has been repeated. Initially, using this formula, we did when there is no tied marks. That is when we use this formula. But when we have such a scenarios, and here for cost accounting, we have a repetition of 70, 70. That is 70 is repeated twice. So that is now when we can say, now when the ranks are repeated, the rank correlation coefficient is formula is adjusted as this 1 minus the whole of this 6 into, you see we have the summation of d squared, just like in the above case here, but we are now supposed to add this tied marks, like plus t1 cubed minus t over 12 plus t2 cubed minus t2 over 12 plus all the way to n number of ties that we have in that data set, over n, of course, cubed minus n. Here t, you have to be aware that t represents the number of ties. For example, down here, as we have seen, 45 is repeated 1, 2, 3 times. So our first t here is, that's t1, t is 3. So when we will be calculating, we know how to get d. So our t here will be 2, sorry, for 3. And for cost accounting, if you watch keenly, you will see that it's only 70 which has been repeated twice. So 70 has been repeated twice. So the next t here, which is the T2 should be 2. So those are the only tiles that we have in this kind of a question. So an example, we can read this question. The score of students in quantitative methods and cost accounting are as follows. That is students 1, 2, 3, all the way up to 9. The quantitative methods marks are 35, 55, 45, 50, 25, 45, 29, 52, 45, and for cost accounting is 65, 70, 40, 70, 25, that is our 45, 50, 52, 46, and 58. Then we are supposed to compute the Spearman's rank correlation coefficient and then comment. So we are supposed to know how we are supposed to give these ranks, and this is the solution. The solution, we agree that we are supposed to get the ranks. We give the marks for quantitative, then the ranks for quantitative methods, the marks for cost accounting, then the ranks for cost accounting. Then we find the D squared, which will be used here, just like the one we did for when the ranks are not repeated. So we are supposed to determine this T, right? So how do we give the ranks? Let us start with the ranks of quantitative methods. The highest one we have here is 55. 55 is given position number 1. The next after 55 is 52, which will be given position number 2. Number 3 will be taken by 50, which will be 3. Number 4, after 50, the next number is 45. But you can see 45 is repeated. 45 is repeated 1, 2, 3. So 45 is supposed to take number 4. Come here down here. 45 is repeated at position 4, position 5, and position 6. So we added the 3 positions. That is position 4, 5, 6, and then we divide by the 3 positions. So we have 4 plus 5 plus 6, it is 15, divided by 3, it is 5. So this 45 is supposed to share this position 4, 5, 6 by 3. So we give them 5, 5, 5, as we have found this one to be 5 here. So position 4, 5, and 6 is gone with 45, 45, 45. So after 45, the next number should be now position number 7, which will be taken by 35, 7. Then after 35, the next number here is 29, which will be position 8. And lastly, 25, the youngest here, number 9. Done. Let's go to cost accounting. The highest is 70. Fortunately or unfortunately, is taking position 1 and position 2 because they are 2. Position 2, 1 and 2. So let us take these 2 positions of 70. Say 70 is repeated at position 1 and position 2. So we take 2, 1 plus 2 divided by 2 is 3, which is divided by 2 is 1.5. So 70 will take position 1.5 and position 1.5. So which translates that position 1 and 2 are gone. So the next one will take position number 3. So let us get the value which will take position number 3 after 70. Which one? After 70 we have 65, number 3. Then next is number 4. After 65, 58, number 4. After 58, we will have 52. to number 5. After 52, we will take 50, which is number 6. After 50, 46, which will take position number 7. After 46, go to 45, it will take position number 8. And lastly, after 45, which will give us number 9, is 40. The smallest, which will take number 9. So we have the ranks for quantitative methods and the ranks for cost accounting. So we are supposed to find the difference between the two ranks. So this is the d squared equals to the difference between the quantitative methods ranks minus the cost accounting ranks, then we square the difference. Okay, this is 7 minus 3. This is 4 squared, 16. 1 minus 1.5. This is 0.5 squared. This is 0.25. 5 minus 9. It's 4 squared, 16. 3 minus 1.5. That is 1.5 squared, 2.25. 9 minus 8 is 1. 1 squared is 1. 5 minus 6 negative 1 squared is 1. 8 minus 3, 3 squared, 9. 2 minus 7, negative 5 squared, 25. 5 minus 1, 1 squared is 1. Then we find the sum of the d squared, which will give us 71.5. So the most important part we are supposed to understand here is on how we can give the ranks of the tied marks or of the tied scores. Right. So since at quantitative method 45 is repeated 3 times and cost accounting 70 is repeated 2 times, then our formula will be like this. So we have two separate ranks. The first one for 45 repeated 3 times, so the first t will be 3, and 70, which is repeated twice. So our next tie 70 is repeated twice, so our next t will be 2, and of course n is 9. So the formula is here. R is equals to 1 minus 6 into brackets the sum of d squared plus now the adjustments that we added here. They are here. These are the adjustments that we did, as you can see from the initial formula. So we are adding plus t cubed minus t over 12 plus whichever the number of ties all the way. So now that since we have two ties of the first tie 3 times and the second one 2 times, so we have t1 and t2, as you can see from this formula. So these are the adjustments we are supposed to make. Substituting the values we have into the formula, we have 1 minus 6 is into brackets d squared was 71.5 plus, as you can see, 3 cubed minus 3 over 12 t1, that is of 45, and the next t was 2, that is 2 cubed minus 2 over 12 divided by 9 cubed minus 9. If you calculate this one, we are going to get 0.383 as our rank correlation coefficient. So the rank correlation coefficient is 0.383, and the comment here is there is a positive, which is weak, correlation between quantitative methods marks and cost accounting marks. So the comment is there is a positive or a weak correlation between the quantitative methods and cost accounting. Done. So to say that sometimes the ranks are given, hence required to directly compute the d squared. If not, just like in the previous examples, then do the ranks. All I want to say here is that some questions we are given the ranks, so you have to read keenly on in between the lines. So some questions they give the ranks, not the marks. Like if, for example, in this one Some cases we will be given these ranks. Student 1, it's ranked 7. Quantitative methods is ranked number 7. Then 2, position 1. Then student number 3, quantitative methods scores number position 3, all the way like so. Sometimes you are given these ranks, so there is no need of now going ahead and determining them as we have done here. So we go ahead and calculate the d, that is the d squared value. So that is the note before. Let us do the next part after correlation. And this one, I think we now understand what is a scatter diagram. Of course, this is a diagram which that's a sketch or a graph which has been plotted but not joined. Scatter diagram, or sometimes it's called a dottogram. So this will now connect us to regression analysis, which is used to determine the line of best fit. So when talking of the line of best fit, coming from the scatter diagram, you see now we have a set of values given in form of x and y, that is independent and dependent values. We are supposed to plot a graph. You plot those points without joining them. That one becomes the scatter diagrams. Now when you draw the line of best fit, you know there are so many lines in between those graphs. But you take the line of best fit. So this one is now used to lead us to regression analysis. Okay, what is that? This is a statistical, that is a regression analysis. This is the statistical method used to determine and forecast the relationship between variables. The variables are said is independent text x and dependent y. It also determines the strength and the nature of the relationship in the variables. There are various types of regressions, but here we are going to mainly focus on linear regression. The method used here is a least square method. The least square method, where the function we are supposed to determine that equation, when talking of the line of best fit, the line. So the line, we have the function which will give us that line of best fit, is found by the least square method, where that equation is y is equals to a plus bx, as we have seen here, where y is the dependent variables, e.g. in supply or procurement, that is a delivery time, or in business generally, delivery time. A is the y-intercept, b is the slope, that is the effect of x on y, and x is the independent variables, for example the distance between the suppliers and the business. Yes, and the nature of the questions that we will face, the first one can say fit in the regression equation. So you are given the set of values, independent and dependent values, that's x and y values. From the values you can plot a graph which will give us the scatter diagram. But now the challenge comes in, how can we know the direction, the trend of the line? So that's when now we are supposed to fit in the line of best fit using the least square method. So the equation can say fit in a regression equation or function. Of course, the equation is a function, the same thing. Or determine the regression equation. Given the values, determine the regression equation. Sometimes they say using the least squares method, fit in or determine the regression equation. What does this mean? Here we are to find the variables or the values of a and b to form that equation or function. So remember, we have this function here, y is equals to a plus bx, of which we have defined the variables. So when we are asked to fit in the regression equation, we are supposed to find the values of a and b, so that, for example, if a is 2 and b is 3, you say y equals to 2 plus 3x. You see, that's the equation of a straight line. So this is the formulas of getting the a and b. Here we go. Here we are to find the values of a and b to form that equation. That is, the value of a can be determined by a is equals to summation of y minus b summation of x all over n, and b will be determined by n summation of xy minus summation of x times summation of y divided by n summation of x squared minus summation of x, which is squared. And I think here we can see the difference between x squared minus sum of x, which is squared. That we have to understand that one. Here we are supposed to square individual values of x, and then we add them. Here we are adding the individual values of x and then square them, square the answer. So that is the difference. Then the tip here we can have is in such a case, we are first supposed to work out b, then a. That is, in such a case, that is for the two formulas, we are supposed to work b, then a. Why? This is the reason. We cannot start working with a because we have a value. We are supposed to use b here. You see, we cannot start working with a because we are supposed to use b. So this now dictates that first we determine b, then the value we get of b, we will now use it at a. You see, now that is why we are saying that the tip, in such a case, we are supposed to start first with b and then a. After you have found the values of a and b, yes sir, now we are supposed to form an equation y equals to a plus bx. That is after finding the values of a and b from these two formulas here of a and b. Now we are supposed to form the equation y equals to a plus bx. Yeah, we are going to see in this example here. Then we can forecast or predict the value of y, that is the dependent variables, given a random value of x. Here is a practical example. A procurement officer wants to analyze the relationship between the distance in kilometers and transport costs in Kenyan shillings for bulk goods delivered. The following data was collected from 5 recent deliveries. That is the data: distance in kilometers, distance 20, 10, 40, 30, and 50. Cost in Kenyan shillings thousands, 5.5, 4.0, 8.5, 7.0, and 10. So here, when we talk of the heading like this one in thousands, so as you can see, if this one is cost in thousands and then this is 5.5, then this means it's 5,500. This is 4,000, 8,500, 7,000, and 10,000. So it is 10,000, 4,000, 8.5 thousand, 7,000, and such. So required, after getting these values from the given set of data, so we are supposed to now using the least squares method, fit in the regression equation or function. That is 5 marks. Using the least square method, fit in the regression equation. And part B, using the equation obtained in A above, forecast the cost of transporting goods over a distance of 120 kilometers. That is this 5 marks also. So here goes the solution. From our equation, the least square method, y says to be a plus bx, and we said a is supposed to be found by summation of y minus b summation of x over n, and b equals to n summation of xy minus summation x summation y over n summation of x squared minus the sum of x squared. Yes, so again we have to be very keen of these denominator values, just like in what we did in the determination of the Pearson's coefficient of correlation, small r. So these formulas dictate that we have the columns of summation of y, summation of x, summation of xy, and summation of x squared. That's from the formula. We need summation y, summation x, and we have it's here. N is 1, 2, 3, 4, 5. So that one, and then we need the column for summation of x times y. That one, x and y, we have them here. Then we need the column for x squared. Yes, those are the columns that we need. But because for this one, summation of x then squared, we will square this value here, the sum of x. Then we square that value. So we don't need this one. Good. So we do this one. This is the table. Distance is independent. Cost dependent. So the costs will depend on distance covered. So that's why from the equation here you can see we are not given x and y. It's upon us to determine which one is independent and which one is dependent. So distance will be independent of costs. So cost will depend on the distance covered. So that's why we are saying that distance is independent. We'll take x, cost y. Now we have x and y. We'll now need x times y, and lastly x squared. So these are the values here from the given set of data. So there we go. So x times y, 110, 10 times 4, 40, 40 times 8.5. So that these are the values. And then if we add this x, y, that is summation of x times y, we are going to get 1200. Right. X squared, the column for x squared, which we are going to use on the denominator here. So 20 squared 400, 10 squared 100, 40 squared 1600, 30 squared 900, 50 squared 2500, which will give us a total of 5500. 5500 here. Then the summation of x, which will be used for both a and b, 150, and the summation of y, which also will be used on both formulas, is 35. And the n, as we have said, is 5 observations. So we agreed that we are supposed to start with the b. So let us take this formula here for b, n summation of xy minus summation of x summation y over n summation of x squared minus summation of x squared. Substitute these values here into the b formula. So b is 5 for n times 1200 for xy minus summation of x, that is 150, summation of y, that is 35 here, divide by n, 5, times summation of x squared, which is 5500, minus sum of x squared, 150 squared here. So if we do this one, we are going to get 750 over 5000, which will be 0.15. So our b is 0.15. So we are going to insert this b value or 0.15 into the formula of a, as you can see here. So a is given by the sum of y minus b, which we have gotten, times summation of x divided by n. So this is the calculation for a. So summation y, that 5 minus b, 0.15 times summation of x, 150, divided by n, which is 5. So the answer is going to be 2.5. So this gives the equation to be y equals to 2.5, the value of a here, plus 0.15, the value of b, x. So y equals to 2.5 plus 0.15 of x. So this is the regression function. This is the regression function, and whatever we have used is the least square method. So the forecasting part. Now, given an equation like this one, we can forecast, because this is the equation for the line of best fit. This is the line which is drawn on a majority of points plotted. The line of best fit. Just create that mental image. This is the line drawn on the majority of the plotted points. So this gives the trend. This is the general direction where this set of data is taking this set of data here. So they are taking this general direction, and you can see our slope is positive, but it's a positive slope, 0.15. So there's a positive relationship. However, it is weak, but there's a positive relationship this from this slope. So in forecasting, y, when we want to determine y, that is a projection of y when x will be 120 kilometers, what we are supposed to do, we substitute the value, will be asked the value of x. So we insert the value of x here. So that is a forecast y when x equals to 120 kilometers. Insert x equals to 120 at the equation, at the regression function. Y is equals to 2.5 plus 0.15x. This becomes y equals to 2.5 plus 0.15 times 120. This one gives 20.5. Y is 20.5. Okay, let us go back. We have 20.5 as the value of y. See, how was y given? Y is cost. Y is the cost, but this cost is in thousands. Cost in thousands. Cost in thousands. Cost in thousands here. So we have 20.5. So this means y is in thousands. So it's 20.5 thousand roughly. So y is in thousands, then the cost will be 20,500. So we multiply this one times 1,000. So which will give us the cost of covering 120 kilometers will be 20,500. The applications are here. Correlation can be used in inventory management, e.g. identifying the relationship between the demand and quantities demanded, or the relationship between demand, that is the price, and the quantities, price and quantities. So of course here demand, that is the price. When the price goes up, the quantities will go down. That's a overview, but we will want to gauge the strength and the direction. we have here under procurement planning, e.g. Getting the procurement planning, e.g. getting the relationship between the delivery time and the distance, weather conditions, etc. Customer analysis, for example, examining the relationship between the advertising expenditure and sales uh, revenues. Risk assessment, this one will be covered in some finance, where we are using these equations to determine the risk. Risk will be determined by this slope here, and there are some coefficients using the other using other, maybe when we will be using other regression methods like multi regression analysis, we will be having an error term. We will be adding an error term to this regression equation. So this error term will assist us, the value of that one will assist us to get the value of the risk, that one. Regression, of course, this one will assist us in forecasting, as we have said, and all of that, of course, will be used in decision making. And this one now calls to the end of the correlation and regression analysis as per the outline is required. But this unit as a whole is very wide and is very detailed. We will, if you have time, maybe starting on now, you can be using the other types of regressions as we have mentioned. We will be using softwares. They are the maybe the mathematical softwares and such. So the unit itself, the topic itself is detailed, but for us, this is what we are supposed to cover. And this one brings us to the end of this correlation and regression analysis.